for people that might not be able to attend our meeting and would like to know what we will be covering here. So our operating agreements, we have a 3-hour meeting, so please stay engaged. If you have to step out of the meeting for a while, do so, but if you are in the meeting, please stay engaged. During this process, with so many different stakeholders represented in this room, we have different points of view, and when voicing our thoughts, we might experience some discomfort with opposite thinking. So I encourage you to experience that discomfort is part of this process. And speak your truth, knowing that you only hold one piece of the truth. And expect that we're not going to have any quick fixes during this 3-hour meeting. This is a process. We're working towards an evolution of a distribution system plan process. So it's going to take a lot of small steps to get there. And please share the airtime with others. Some of us are more vocal than others. Let's provide space for people that might require us, the extroverts, to step back for them to voice their thoughts. We also have the chat for people that don't feel comfortable using the camera or microphone. We would like to hear your thoughts in any way that you feel comfortable sharing. And let's be courteous when we're speaking to each other. I think that's very important. As I have an 8-year-old, and every day my request when he goes to school is be kind. I think that's what I will say to this room. Let's be kind to each other, and let's start this meeting. I will be providing some updates on the community engagement, and as I mentioned on our updates on upcoming meetings, PGE has heard our stakeholders that these meetings can be pretty thick and technical, and that we have other voices that would like to participate. So we have created another venue, the community workshops, that are non-technical. And we're trying our best to learn to share this process in a non-technical manner, leaning heavily on our CBO partners. Our next meeting is next Thursday afternoon. And if any of people that consider themselves part of the audience for this meeting, you are welcome to join us. You can send me an email, and I am happy to share with you the link for that meeting. On the CBO engagement, the Clean Energy Project was awarded the Energy Trust of Oregon grant that applied. So we are partnering and leveraging in order to do more community engagement with them. The non-wire solutions, non-technical materials are going to be shared during our next meeting next Thursday. Very excited about that. Thank you for our CEP partners on helping us translate that very technical document to a non-technical. And finally, we were able to hire our 2 community engagement DEI roles. And on our next meeting, we will make sure to introduce them to you. Very, very excited for them to join the team. And those are all my updates. I would like to invite Pin Lu to share with us the updates on the water heater front. Please.
Hi.
Let's
Good
welcome
morning. Thank y'all for letting me join you this morning. So for those of you who were at the DSP last meeting, my name is Bin Lu. I am the lead product developer for the Smart Water Heater program, which is focusing specifically on single family water heating. So could you go to the next slide, please? So today, what we're going to do is we're going to have some discussions around some design considerations that we have. So my ask to you is, I'm going to present 3 different topics of different parts of the design that we're at. And what I'm looking for is like your gut reaction to it, right? Like the thing that I'm going to present to you, does that make you feel weird? Do you think customers will look at it in an interesting or different way? And what potential, obstacles you might see, or things that might just not jive, okay? And please just know that this is not fully designed in any way, shape, or form. We are still in the beginning design phases, so everything's on the table. There are no wrong or right answers at this stage. So if we could go to the first topic. So this is to set a little context. When we looked at the service territory of PGE and we looked at our single family water heater market, it's about 50-50 gas and electric. So you see on the right-hand side, it's gas, propane, solar, water heaters make up about 50% of our market. And then on the left-hand side in the different shades of blue, there's the electric. About 88% of our market sits within electric resistance, and about 12% sit with heat pump water heaters. And we've confirmed that with Energy Trust and with NEIA. Now we know that this current state of the world, that's not what we want as a region. We know that we want to expand that heat pump water heater segment to be larger, and we just need to work with folks like y'all to figure out what does that look like over the next 10 years. What realistically can we do together, right? So if we go to the slide after this, what we're trying to consider right now is what does heat pump water heaters look like within our pilot? So in the heat pump water heater space, there's a couple of different variations that we can do. So if we look at like the baseline qualification, there's Energy Star. So Energy Star certifies heat pump water heaters of all different classes, and they tend to be not as restrictive in their qualification as NEIA is and Energy Trust is. So there's another layer that we could go after and have qualification with, aligning to the Energy Trust qualification. And then there's also this aspect of adding another component to heat pump water heaters to make them have more flexible load capacity. So when you think about water heating, the electric resistance, we need to have 2 heat pump water heaters to equal the same amount of flex load capacity as 1 electric resistance. So for us, we're thinking about the different ways that we can help advance the energy efficiency of the heat pump water heater market, but also how do we add the flexible load capacity? The rub for our customers there is it's a significant cost increase to add a mixing valve, which is our current estimates are about $600 extra on top of the extra that customers are paying to get a heat pump water heater in general. So before I open the floor for discussion, there's some design considerations that I want to put out there. So PGE, we're looking to support more than one solution, which is why we are going to accept electric resistant water heaters, but also accepting whatever qualification of heat pump water heaters we land on today in other forums. We want to promote energy efficiency, and we want to be able to coordinate the message between PGE and Energy Trust. So we're not creating any confusion in the market, but we're really meeting customers where they're at. So with that, I want to see, is there any questions, gut concerns, thoughts?
We have one on the chat.
So in the chat, it asks, does the 2 electric water, or electric resistant water heater equal 1 heat pump water heater math for flexible load capacity. Take into consideration the decrease in energy usage that a heat pump water heater provides as well. So I just want to make sure I clarify. It takes 2 heat pump water heaters to equal 1 electric resistance for the flexible load capacity. Yeah, no worries, Jenny.
Yeah, I think,
So,
and oh, just real
Mhm.
quick, this is Andy. I think, Jenny, the short answer is no. We're just talking about sort of the capacity around peak hour within a day, not the annual energy consumption. So you do drop the, the demand from energy efficiency, but then looking at what is left to shift, that's what I think Ben is focusing on, is that flexible load
Mhm.
capacity.
That's right. Does that answer your question, Jenny?
Thanks, Ben. Can you hear me okay?
Yes.
Yeah, I think I understand, but I guess I just want to clarify. So not necessarily taking into consideration the annual energy decrease in energy usage, but is the daily decrease in energy usage taken into consideration, or are you purely looking at the flex capacity, the ability to the difference in what it can provide for demand?
Andy, are you able to help me out with that answer?
Yeah, I think we're not looking at a daily energy budget, I think, as the difference. It's the difference in demand. So, like 0.15 or so kW during average system peak for a heat pump water heater, and 0.35 or 0.4 for electric resistance. And so you can drop the load from doing energy efficiency, but if it's not able to respond to grid signals and things like that, if it's not flexible in that way, then it's just a load reduction, and we don't count that as flexible load.
Mm-hmm. Any other questions, concerns on this topic? Okay. Well, thank you. What we'll continue to do is we'll continue working with our other market partners to figure out like what do we want to do in this space and how to not cause confusion. So hopefully, I think in the June meeting, looking at the calendar that was presented earlier, we'll be able to come back and say these are the qualification levels that we're going to allow for the pilot. So if we could go to the next topic. So what we're exploring right now is possibly having the smart water heater program be an opt-out enrollment. So what that means is when we looked at the customer experience and the journey of it, the customer makes a decision with their installer's input around, do I want to have a electric water heater, a heat pump, or an electric resistance? Like, they make those decisions. And what we think we can do is we can work with the installers directly, and we've done this in the test bed, and Energy Trust has done something similar in their work as well, of connecting, working with the installers to just connect the water heater automatically, right? So getting them the correct modules that do the connection. And then once it's connected, we already know roughly where it is based on getting a serial number. So in that sense, the customer doesn't actually need to do anything extra to do that. So as we looked at how we can efficiently acquire customers, once they're connected, we think we could potentially just automatically enroll them into the programs, and then provide them some feedback or some information somehow to say, hey, you are now enrolled in the program. This is a slight variation on what we do in the multifamily water heater pilot that's currently going. In that particular pilot, customers their water heater is already connected, and so it doesn't change whether or not there's a move in, move out, which is more beneficial to the strength of the pilot, right? We don't have to then go and try to reacquire a customer as they move in and move out. And we think that it will help reduce the administrative burden to recruit just in general. We think also that by having this opt-out program, it allows us to, because of the way the customers interact with the demand response aspect of the program, they basically never notice that it's happening. Unlike when you're doing a smart thermostat or EV charging demand response, where customers are fully aware that they're the heat in their home is changing, or they're not being able to charge their car at that moment. And for this case, they're really never seeing it. They're never feeling it because their water heater shuts off, or the water heater opts out automatically of DR events if they're using it. So we think that by all of these considerations, that being able to do an opt-out program is beneficial for both PGE and the customer to not cause a lot of confusion. So with that, I'm going to open up the floor and see if there's any questions or concerns on this particular consideration. Hi, Nick.
Hey, Ben, good morning. Say, I just want to repeat back one thing I heard, make sure I got it right. If somebody is participating in the program and the water heater is actively engaged at the time an event is called, it overrides that event for them. Is that correct?
That is
Okay.
correct.
Okay.
And we see that in the multi-family water heater program right now. It's a pretty standard process for all of the water heaters that participate.
Okay, thanks, Ben.
Sudeshna, did I pronounce your name correctly?
Yes, hi, I'm
Okay.
Sudeshna with Oregon Citizens Utility Board. I was wondering, I know, for smart thermostat, you are automatically, not enrolled in the peak time rebate program anymore. How is this, the water heater, demand response going to interact with the peak time rebate?
Yeah, that's a great question. So we believe that we will have to unenroll customers from the peak time rebate program if they have a smart water heater that's also enrolled in the smart water heater program. That then basically we just don't want customers to double dip, because in the peak time rebate program, right, like customers are paid to use less energy and change their behavior. But if they're in the water heater program as well, we're already managing their energy usage for their water heater. So we wouldn't want them to be able to double dip in that sense. Does that make sense?
Yeah.
Do you have any concerns?
I mean, it is. I'm just thinking. I mean, there are other sources of energy use too, and so I mean, I'm guessing the water heater will probably consume a big chunk. So just having a control on that, and then unenrolling, I mean, suppose this person does not have smart thermostat. So yeah, I mean, probably the water heater, then for this person, the only option to participate in demand response is through the water heater program, right?
Yes, if they're not in the smart thermostat program. Well, they could also, if they have an EV, they could participate in the EV charging program as well that exists.
Okay. Okay, all right. Thank you.
And then there was a question that asked, can you describe the mixing valve benefits in more detail? is it that increasing tank temperature beyond scalding temps allow for more flexibility for load? So actually, I'm going to ask Andy, would you mind helping me explain the technicalities of that?
Sure. So yeah, it is related to sort of being able to superheat the tank over and above like what would normally be a safer limit, and then you can essentially have your heating element on for longer to basically absorb. If you're doing a preheating event, you can essentially not only have it on for longer to absorb excess electricity before the event, and then of course then with a hotter tank temperature, the mixing valve essentially allows the water coming out the other end to be at safe temperatures. So you can then maintain that heated water for a longer period and get a longer effective load shift. And if there's anyone on the call with more of a technical description, if that's not scratching your itch there, James, others can jump in.
Fred, did you, or actually, let me make sure. Did Andy's answer make sense before I go to Fred? I'm going to take that as a yes. Fred, do you want to go?
Hi, it's Fred Hewitt, Northwest Energy Coalition. Hope you can hear me okay. I had to be on a call, so I missed a little bit of this. Could you mention how many customers you expect to be in this pilot?
Yeah, so we're hoping from the start of the pilot that we'll be able to get about 2,000 water heaters annually. Now, that doesn't include the new construction piece. We're talking with Energy Trust right now to figure out operationally, how can we coordinate, and then how much does that increase the number of water heaters to expect in this pilot?
Okay, thanks. Yeah, this is, I guess my reaction to this is it's a bold initiative. I hope it works. We've been thinking a lot about water heaters for several years now, and I was following it a little bit involved actually in the 2018 field test. It's of all the different demand response or flexible load measures, it's probably the one that has the least impact on customers potentially if it's done well. The 2018 test didn't show any real problems, and they were running at that point. The program was running 1 or 2 events a day for months, and didn't develop any major customer, pushback. Maybe a little bit, but and so I have high hopes for this, and the opt-out aspect ultimately I think is where we need to go, but getting there requires having a very clear understanding of what customers are interested in doing, willing to do, giving them compensation or other benefits that they want. And not everybody's going to want to be in the program, but I think that this is a case where getting broad participation is a really desirable thing, and the resource is a really, really good one from an operational perspective.
Thank you, Fred. Yeah, and what we learned from the multifamily program is that about less than 1% of customers end up opting out for any way, shape, or form. So we think that we'll get high participate, or at least high retainage of customers once they get enrolled, and then we're working out how do we, for the single family market, give opportunity to opt out. Right? Because, there's going to be some customers that just don't want anything to do with the pilot whatsoever, and they'll opt out indefinitely until they move or no longer reside in the home. And then there's going to be folks that kind of get it, but they will want to have the assurance of hot water when they have, a family reunion coming to their home. And how do we help them have hot water for the week that their entire family comes and stays at their house, right? Or maybe they just need it for the one day. We're looking at the different options. So I think the second sub bullet of providing multiple ways to opt out, there's we already have an established phone process, so you could call PGE and opt out. And we're looking at, can we offer you something more digital in the mobile aspect? Can we provide something in the mobile app that we have? How do we make it very accessible to you as a customer?
Yeah, that makes total sense. And I think it's also important, not just for this program, but for the future, for a broad-based program like this eventually, we hope would be, to establish a good relationship with customers where they feel confident that, you know, their choices are being respected and that they're getting some benefits if they're in the program. And it's all sounds easy to do, but we know from the test bed so far, it's kind of tricky to do that. And so I wish you well, because I think this is a really good idea.
Oh, good. I'm glad, because when we floated it, I was like, are we crazy?
No, we given that the CTA 2045 requirement will, at some point when the supply chain finally gets worked out, you know, be every electric water heater will have to have that. That's, you know, we don't want to strand that asset. And water heater, if you add it up, it's a really big resource. And operationally, you know, like I said, the shape of the water heater daily use shape, load shape, is peak coincident, a fair bit of it anyway. And especially with the heat pump and the mixing valve, that was I'm sure you know about the Brattle NRDC study a few years ago from, you know, looking at California primarily, but that really will dramatically expand the resource value of this and help provide better service to customers.
Mm-hmm. Yeah, thank you. So I just have a few minutes left, and Quinn, I'm actually going to answer your question in the next slide, if that's okay. So when we look at the incentives and the rewards that we're able to offer, because of the general low flexible load capacity available, you know, we have very few dollars that can satisfy the traditional reward system that we've put into place. So in a traditional reward system, we offer you an incentive up front to help with the installation, and then we offer you some sort of participation dollars at the end of each season. Now, because of the low flex load capacity and the need to be cost effective as a pilot, what we're looking to do is take all of the total available incentives across the pilot and front load it to really help customers afford the cost of the installation. Because regardless of what they're doing, we know that the first cost, so the installation and the equipment costs, are great barriers to the decisions that customers make. So what we're doing is we want to explore some value-centric rewards. So that's really non-monetary incentives to participate in the flex load events. Now, I don't know exactly what that'll be. We've been exploring charity donations, exploring going back into the community. How do we do those things? We've also explored modeling after the multifamily program and doing the Chinook book, but there's some issues with that because it's only specific to the metro, and we're trying to look to service the entire territory and its customers. So Quinn, to answer your question, I don't actually know how it will compare to PTR because it depends on the customer's home and kind of how they can, you know, if they have AC or central heating versus baseboard, like how does that kind of affect into it? We want to take a look at that before we make any decisions. But I guess in the last minute or so, because I know we're over time, is there any gut reactions to this idea that we're trying to consider? Fred, I don't know, is your hand up for the last one, or did you want to comment on this one?
I thought I'd put it down. Let me try that again.
Okay, no worries.
Yeah, it's a little difficult because you have to click something you can't see. I mean, you have to find it and then do it, which is...
I do it wrong all the time.
Yeah, Teams.
well, what I'll do, because I know I've thrown a lot of topics at y'all. If we go to the next slide, there will be my contact information. So feel free if something comes up and after you've thought about it, just send it to me. Let us know what you think. We'd love to have further discussion with you, and we'll work with Shadia to come back and do some more, float some more topics that we're exploring as well. So thank you all very much for your opinions today. We really appreciate it.
Thank you so much, Vin. Our next presenter will provide a quick update on the Solar Innovation Community and Community Partnership. Let's welcome Kathy Wagner.
Thanks, Shadia. Good morning, everyone. My name is Kathy Wagner. Like Ben, I'm a senior product developer at Portland General, and working with the group here on a collaborative process to bring solar to more of our residential communities. So just wanted to provide the group here today with a quick update on how our co-creation process is going, some of the lessons that we are learning along the way, and I will say personally, I'm learning a lot along the way with great humility. So thanks to everyone as we kind of learn as we go. I'm very appreciative for that. So let's maybe go ahead and transition to the next slide. So again, this is just sort of an overview of our overarching goals, which is, PGE is very interested in ensuring there's equitable decarbonization and resiliency for all of our customers. And we're especially interested in ensuring our LMI and environmental justice communities have accessible and equitable access to residential rooftop solar. So a couple months back, we invited the team here, the group here rather, to join us in a collaboration process as we look at single family offerings as well as multifamily offerings. And a number of you agree that you'd like to participate, which thank you very much. And so we're focused right now on multifamily LMI offerings. And I wanted just to give the group here an update on how our first session went and some of the learnings that came out of that. So we can go ahead and transition to the next slide. So here's just a quick listing of our collaboration team. And we have a new member who joined as of, I think, gosh, Angela, yesterday. And that is Ryan Sheehy, and I'm not sure if I'm pronouncing the last name correctly, also from OSEA. And he is a member of their fleet development team. So our team is growing. And so let's go ahead and transition to the next slide. So we had our first kickoff meeting on February 25th. And again, this is a really great learning opportunity for all of us because this idea of co-collaboration is a different process, quite honestly, than PGE's, I'm going to use air quotes here, standard development process. And so this is, again, an opportunity for us all to learn how to work and develop with that customer centricity in mind. And so I think what went well with the meeting was we had great representation from community organizations, from government, ETO, and PGE. The team was very engaged in the process. PGE had prepared a kickoff activity for the team, which is a process that we typically use to kind of inform ideation and brainstorming and eventual product development. And we did capture, we went into kind of an ideation brainstorming session, and we did start capturing some pain points for our ultimate consumers or end users rather, which would be property owners, multifamily, LMI property owners, developers, and tenants. And then we kind of did a pause. And the team very clearly said, number one, we're moving too fast. The second thing was that I think our desire for speed and action got in the way of building alignment. And I kind of just want to pause here too and say, I've really reflected back on this process. And one of the things I can say is that I think that when we had our kickoff, the team had expressed interest in making sure we have all of our, again, those target customers represented. And I kind of thought, I just need to explain how the PGE development process works. And once I explain that, it will be clear that, our process typically is we as a group kind of develop a hypothesis around what the customer pain point is. We then do primary research with those customers to validate that, and then kind of move through the development process from there. And to be honest, even having worked at PGE, I've kind of felt like there was a miss in that we didn't have customers engaged in that additional ideation work where we were developing that hypothesis. And the team during the course of this activity clearly felt the same way. And it was just kind of, again, I will say a revelation to me that it's like, this collaboration process is not about PGE saying, this is how we're going to do it, which I realized personally I was doing. And, I appreciate the team calling me out for that and just saying, you know what? We're not here necessarily to follow the PGE process. We're here to define a new process that really supports collaboration and co-development. So I think that was a big learning that came out. So again, we didn't have the right folks at the table during the course of that meeting. We agreed that we would pause to make sure that when we do reconvene, that we have those property owners, the developers, and the tenants who can speak directly to their pain points. So we are regrouping right now. We're looking to augment the team with those additional end users to make sure they have a voice at the table. We're going to realign to make sure we all have that same common shared vision, and that we are moving forward with a process and goal that is common to all of us. So right now we're looking at having our follow-up meeting the week, which is our reset now, which will be the week of hopefully April 11th through the 14th. So we'll come back after that session and just update the group. But, I think that this activity just already has been really, honestly, an awesome, little bit bumpy experience, but we are learning a lot, and we're learning a lot about how to collaborate, to be real, true collaborators. And so I just want to say thank you to every member of our team to date who has kind of brought that forward. And I'm just looking forward to continuing on in that spirit and that vein, because I think that we're going to bring some really great solar resources to our communities as a result of that. So that's my 10-minute update before our break. Does anybody have any questions on that they'd like to ask? I'm going to take that as a no, that everybody is ready for a coffee refresh.
Thank you, Kathy.
Awesome. Thank you, Kathy.
We'll have you on our next month with more updates.
Awesome. Thank you.
Thank you. Well, we have arrived to our 5-minute break. Let's meet back at 9:50. Let's stretch our legs, refill our beverages so that we can attend our next meeting with Jennifer Galloway. So I'll see you in 5 minutes, guys. Hi guys, we are at 9:50, ready to continue with our DSP presentations. Joe, would you like to please introduce our next presenter?
Sure. Good morning, everybody. Joe Boyles, PGE, and thank you all for carving out time this morning to come with us. As Shadia had mentioned in the tee-up to the meeting, these next couple of topics are pretty dense, and I want to take this time just to kind of level set, make sure everybody's kind of in the right mind space as we get into them. I think what we want to avoid is that the written DSP, the document we're going to submit in August, is the first time that you get exposed to some of the data and concepts that we need to publish in order to respond to the requirements. So the next two presentations are going to be a bit of a deep dive that allow you all to get exposure to the grid needs analysis process, how we develop solutions, how we choose which solution to pursue. So we're going to do it in the context of a kind of a traditional distribution planning investment, so a substation. And Nahit will do it in the context of non-wire solutions. So representing a non-wire solution candidate, how we identify it, and the data that we use to inform the solution. For Jennifer's presentation, it's a lot of slides. So I think it's going to be most effective to run through the slides quickly once. So take like 10 minutes to orient people to the process, like end to end. And then Jennifer will go back to the beginning and we'll step through it and allow time for questions and conversation about the individual pieces of the process and how we get to the conclusions that we arrive at. I think it's fair to say it's dense enough that we may not get through it all today. And there may not be questions we can answer today. We will come back in April and do it again or pick up where we left off. So I don't think we have to feel rushed in getting through it. I think it's important for folks to start getting their heads around some of the activities that we do on a regular basis, but also for you to kind of educate us on what's important to you, because that is one of the thrusts of the DSP requirements, is to figure out what information is important to stakeholders so that they can feel like they can contribute to the process or know where to plug in. So with that said, go ahead and move to the next slide, Shadia. So just like I said, we're going to walk through an example of a substation that we've built. And basically from soup to nuts, like how did we arrive at the need to do this? What were the alternatives? What data did we consider? And then how do we make that decision? So as I said, Jennifer's going to run through it quickly once and then go back to the beginning and do it again for an actual walkthrough of each step. So next slide. Actually, the next three slides are kind of a there's the distribution system. So this is just orientation, things that we've provided before. So anybody reviewing these slides after the fact can get this data. So go ahead to the next slide. Our representation of the way things flow from a point of generation to households. And the next slide. The goals that we strive to achieve in the distribution planning process, right? So safety, reliability, meeting customer needs, as determined by like load growth and new development, meeting our internal standards, and doing basically the least cost, least risk solution implementations. So next slide. We talked about this before. I think we've dropped this concept a few times. The current cycle we're in is the 2023 planning cycle. So you can see, based on that red line, where we are today. So the solutions that we're proposing now for implementation in 2023 were identified in 2021. So that's a lot of the content that's going to make up the DSP. And a lot of the input and conversations we're having about incorporating additional data, new perspectives, customer engagement and collaboration, we're trying to incorporate in the 2024 cycle because that's the one we can catch up with, right? So we're right at the front end of that cycle. We've got a new forecast. Andy provided some insight into that in the past couple of meetings. And we're going to leverage that forecast to start figuring out how to incorporate DVRs and some of these other perspectives into the planning process. So using 2023 to describe how we have traditionally done the work and aiming to incorporate changes in the 2024 cycle. And I think you'll probably see this slide again and again, just as a level setting and orientation piece. So before Jennifer jumps into the details, does anybody have any questions or want to add to that? All right. I think we can take it away, Jennifer.
Joe.
Oh yeah, go ahead, Steve.
Hey, Joe. Hi, this is Stephen McDonald with Teammix. How you doing? Thanks for this diagram right here. So I'm curious though, the current process you're implementing in 2023 plan, is that going to incorporate all the feedback from the stakeholders that to date about changing that process going forward? So engaging stakeholders differently, figuring how to incorporate different solutions and stuff, or is it going to just be the same process just in 2024 and we're at the front end of it?
Our goal is to do those things in the 2024 process. I think that's the simplest way to say it. The opportunities to do a lot of those things passed in the current planning cycle, right? Like really having people an opportunity to understand the solutions that are being pursued, the needs that were identified. Like those were activities that happened last year for the most part. So I think best case is we could do that in the upcoming cycle. I think opportunistically there are little tweaks that we can incorporate into the 2023 planning cycle, but in large part we're focused on the next planning cycle for changes, and that's what will be described in the DSP.
Copy. Yeah, that's good. Thank you.
Yep. So no other questions. I'll hand it off to Jennifer.
Hi, everybody. For those who don't know me, Jennifer Galloway. I'm the manager of distribution planning engineering here at PGE. I am still fairly new to the role, started back in September, so bear with me if I don't have all the answers today. Just want to start with some of our guiding principles when we're looking at capital projects. So planning to peak, and again, this is the current state. So there are things that are going to be changing moving forward, but for the current planning process, it's planning to peak. So plan to serve customers even at extreme temperatures at the largest power demand at any given point of the year. So if you think back to June of last year, we wanted to make sure that we are planning to that kind of load level. Planning criteria for equipment loading. So we target 67% for our distribution feeders, the lines coming directly out of the substation, and 80% for the substation transformers. And this is so we have capacity to move load around on the system when we're doing maintenance or when we need to restore customers for an outage. Targeting system flexibility at both the transformer and feeder level so that we can pick up all load by switching to other equipment for the loss of a single element. That could be a distribution line or a transformer. Customer-driven projects take priority, so large housing developments, manufacturing facilities, industrial parks, those we have to do. We have an obligation to serve. We need to make sure that those get done. And then we also want to ensure that new infrastructure is planned for the long-term forecasted load in the area. So ideally, when we implement a project, we aim to not have to do another project on the affected equipment for at least 10 years. And sometimes that works out, sometimes it doesn't. Like I think of the North Hillsborough area, for example, there's a lot of industrial load growth there. So that particular area, it hasn't quite worked out, but in other parts of our system, it has. these, I think you guys have seen this before, but these are the 7 steps of the current planning process. So what the problem is, where it's located, running analysis to find solutions, looking at the limitations to the solutions, the benefits and risks, if there's any additional impacts to the solutions, and then ultimately recommendations. So the project I'm going to walk you through today is called the Rock Creek Substation. This is a project that is already complete. So, but I'll walk you through the process of how we did the planning behind that. The project is a new substation, 2 115 kV transmission lines, 1 distribution transformer, 3 13 kV distribution feeders, so lines directly out of a substation, to provide capacity for, there's a new North Bethany community development and also system flexibility for existing infrastructure. The project timeline, Washington County developed a North Bethany community plan in 2012. In 2013, we performed a grid need analysis to determine if the existing Bethany substation, which is south of the area, could be expanded to serve new load. Property purchase in 2014 when we determined that we could not expand that Bethany substation. Once we identified a piece of property, we then have to figure out what we're going to build from that specific substation location. So that was done in 2014, 2015. We had originally planned to complete the project in 2018. The actual completion was in 2020, and I'll get into that a little later as to why. Overall project cost, incurred costs, $14.3 million for a substation and $0.54 million for the new substation property purchase. So this is just a summary of what the problem is, like what the drivers and identification tools that we have here. So in this case, we have, some urban growth boundary expansion ultimately and zoning changes. So this was a community development plan, but we can have other things like, new large load additions. That can be something like a data center. It could be something like a new Amazon facility, for example. Safety is always our top priority. Substandard equipment, so aging infrastructure. Identification tools that we use the SIME software, but we're looking at the feeder loading, the reliability. We're doing a full system assessment for when the system is most stressed. And we also have a separate group called our Asset Management Planning Group that has asset risk models developed. So leading into problem identification. So we reviewed area community development plans. So looking at city and county economic development websites to determine where load may be added to the system in the future. So this is something that our distribution planning group does on a somewhat regular basis. We also have our government affairs team engaged to inform us of where some of these new developments could go in the future. New large community development in the North Bethany area identified, required a plan to serve new load. We did a review of the system peak loading on adjacent substations at the time, limited capacity available to reliably serve the large new community. This is the new community development for North Bethany and a map of the zoning. Since I'm going through this quick the first time, we can circle back to this slide and I can explain in more detail. This is just a summary of the load forecast. This is another one we can circle back to. Ultimately is about 16.7 MVA projected peak load. So where is the problem located? That's looking at the area affected by the problem. What is serving that area now? Forecasting what is our load forecast for the existing infrastructure, setting up the models to make sure that we are studying everything that we need to study. So like I mentioned, we first determining the infrastructure in the focus area that exists today. So we identified Bethany substation, served that area with a couple of feeders, and then the West Union Cornelius Pass feeder was adjacent to the site. And so our study area, because we were looking at the area that is being served now, we're looking at the Bethany substation. And so then we include all substations and distribution feeders that tie to the Bethany substation. So this is our pre-project service polygons, essentially. The purple is what our Bethany substation, you can, it's a little small, but the little circle that says Rock Creek substation, that's where it ultimately ended up. And then West Union substation service polygon is in the teal color. And this is just a diagram showing all of the feeders that we included and substations that we included in our study. So these are all that tie to the Bethany substation, Cornell, Oak Hill, Sylvan, and West Union. Then we move into the current state analysis. So we're looking at what the state of the current system is. We can have existing issues that we need to resolve, and also see if we're running contingency analysis, see if we have full redundancy on that part of the system. So our current state analysis showed that we had high and low voltages on sections of line sourced by Sylvan and West Union substations. And this primarily was due to high neutral current flows. And what that entails is that sometimes when we are adding like new housing developments to lines, there's 3 wires on the pole, and those are each phases. And sometimes it can end up that we are attaching a bunch of residential developments to the same phases when ideally we would be balancing that across the 3 wires. And so that can lead to some unbalanced loading on each of those wires. And we have to take steps to move that load to a different wire. So again, we are the sources to the area were from the Bethany substation. So we performed further analysis to examine the current state of Bethany, N-1 contingency analysis on feeders and transformers for both peak summer and peak winter. Ultimately, we concluded that we were in a state where we could not pick up all the load in the event of an outage if one were to occur during peak loading conditions. So we need a capacity addition. So now we move into the solution analysis. So traditionally it's planning to peak, wired solutions, reliability based, emissions agnostic, looking at things like reconductors, substations, voltage regulators, or even just adding equipment to an existing substation. And Nahit will touch on some of the stuff for the non-traditional solutions in the next presentation. So the first thing we like to do is evaluate adding capacity at existing substations first. So we looked at Bethany, Cornell, and West Union and determined that we needed a new substation to reliably serve the load growth. And we can come back in more detail to this slide as well. Let's go to the next one. This is a slide that shows the sites considered for the new substation. So we do have some limitation on zoning in terms of where we can actually site a substation. And I can talk about this in more detail when we come back to. So we perform power flow studies using that SIME software to determine the plan for the new lines from the substation. So all feeders that were identified in that location specific characteristics are included in the study. The load forecast at the time was for the PGE system load to remain flat for the next 5 years. That is on the current system. That did not include the North Bethany Community Development Plan. So we have the criteria that the kind of thing that I talked about earlier with the base case, so that we don't want feeders higher than 67%, transformers higher than 80%. We also have what I've talked about, contingency analysis. So when you remove a feeder or a transformer from service, you want to be able to pick up all of that load during peak conditions. So we have 3 feeders located within a quarter mile of the Rock Creek substation. We looked at how we can offload those 3 feeders to avoid significant infrastructure build out and provide capacity to serve the new load growth in that North Bethany community area. When we have our models, even though we don't know exactly where the load is, we can add some spot loads to the model to simulate that the new load that is being added to the system. And just keep in mind that the speed of which load materializes is somewhat unknown. Like we have insight into when the houses start being built. There are also plans for when houses be built and things get delayed on a regular basis. And so, it's not that we needed to add all of the capacity immediately, but we needed to make sure that we make provisions to add capacity in the future, because what we didn't want to do was build a substation for just a small portion and immediate load and then have to go and build another one or expand that substation later. So this is just a diagram showing pre-project and post-project service polygons. So you can see Rock Creek Substation took a good portion of Bethany and West Union. Then once we have our solution, we look at the limitations to the solutions. Does it meet the problem statement? Were there additional discoveries found? So something like the neutral current issue where we had the unbalanced loadings on the wires. So that was something that we discovered and needed to do on top of this new substation. Is the solution meeting customer and community needs, regulatory compliance guidelines, system needs under that base case or contingency scenarios? Are they optimal? Are they constructible? And is the duration valid? We don't want to be going in year after year into a substation. So some solution limitations that we found was that while that substation provided full N-1 feeder redundancy for Bethany, it did not provide full N-1 transformer redundancy for one of the transformers during peak summer conditions. And transformer redundancy can be harder to achieve. We did identify that a capacity addition at Sylvan could be a potential future solution to provide full N-1 transformer redundancy at Bethany. The solution didn't build out infrastructure to serve the entire North Bethany community plan. Like I said, we don't always know the exact timing, but we made provisions to accommodate future load growth with room for a second transformer at Rock Creek Substation. Benefits and risks of solutions. So we're looking at, benefit versus cost, risk reduction, some savings, resiliency, outage duration and frequency reduction is always a great thing as well. So we perform asset management analysis for most distribution projects. And I say most because when we have things like large load additions, like I talked about, like those are considered must-dos for us. We have to do something to serve that load. So we perform, but for things like where you can offload a new existing substation with a new substation, or if you're replacing assets, we look at, the reduction in risk and consequence and years to replacement. How many extra years do you have as a result of this substation? And consequence of failure is really the impacts that the failure has on our customers, our employees, and our assets. So benefits and risks of solutions, more substation capacity and ties to adjacent substations gives us more flexibility and resiliency in a planned or unplanned outage scenario. We did not consider non-wire solutions back in the day. However, it would be difficult to serve a new community of this size with this much load with a non-wire solution, because we have to provide that base level of service. We have to put wires in the ground to serve this load. We can't just serve new homes with a non-wire solution. We have to build physical infrastructure to serve it. And a risk is that the load was not going to materialize in the expected timeline. And so what we do every year in the portfolio stage is evaluate all the projects that are in the portfolio during that given year and determine if it's still prudent to execute on the project in that time frame. And so this is a case where, we expected it to be completed in June 2018, but it was delayed to June 2020. And part of that was because the load did not materialize as quickly as we thought it would. Then we're looking at additional impacts to the solutions. So, community, customer, environmental impacts. complexities. Construction sequencing can be a really big deal when we're doing upgrades to existing substations. With newer substations, it's not as complex. Portable equipment scheduling is something that is also with existing substations. When we're doing a big project like we have to replace a transformer, we can't just take all those customers out of service for many months. We put in a portable transformer device to be able to serve that load while we're doing that work. And of course, safety, like I said, always our top priority. So we had some community impact requests when we were going through the development process for the new substation, developing a mitigation plan in the event of a fire, performing environmental analysis to ensure that the water supply is not contaminated, and then undergrounding distribution lines in front of the adjacent historic church and the new substation property. So another thing that occurred was that, and it can be a little hard to see, but that taller pole that's in the distance here, we gave the community the choice on color of pole, silver or brown, and they chose brown. We also have landscaping to provide screening, which is required per the permitting process, but we solicited input from the community in terms of the specific landscaping that we would use. We are limited in some extent that, of course, it cannot be too high and then get into the lines, but we did work with the community on specific landscaping. And this is a picture of the final substation. All right, so let's go back. Yeah, this is just a summary of that 7 steps again. So let's go back. Let's keep going here. Shadia, let's go to the community development slide where we had the zoning and such. There we go. Yeah. So, you know, a lot of this you can see is that light yellow, that's 6 units per acre. So there's some really large homes in this area, you know, because that's not a small amount of property that is identified for 6 units per acre, but there's some pretty significant sized homes in this area. You know, and each of these different colors identify how many units per acre. So there's some townhomes in that area. There's some smaller homes in that area. There's a lot of big homes in the area. You know, there's also things on here where we have some mixed use type of development. So that can be something like where you have a commercial business on the bottom floor and some residential homes above that business. The institutional load is the PCC Rock Creek that is there, Portland Community College Rock Creek. And then this also identifies areas where you have like wetlands and neighborhood parks. And of course, we always try and avoid wetlands when we're doing any line. So that information is always important to us as well for routing infrastructure. Go to the next slide. So when we are looking at new load, new community developments, that is, we are looking at other neighborhoods and seeing, you know, what kind of demand are they showing? And maybe we can use that to develop our projection for this area. Back then we did an average, so it was basically 4,000 kW per unit. As this development has been building out, because it has such a mix of types of houses, we're able to use this development as kind of a model for some other developments that are being done in the area right now. So there's some developments in the South Beaverton, North Tigard area, some large new housing developments that we're able to use the actual loads from this area in order to inform how much load will be in that in those areas. Commercial mixed use, you know, we didn't know exactly what type of commercial or mixed use there would be here, but just based on other neighborhoods in the area, we were able to get an estimated load for that. And then institutional use is PCC Rock Creek. Let's keep going here. First, let me stop. Does anyone have any specific questions or want me to go to a specific slide? Okay, let's keep going here, Shadia. Let's go to the next. Oh, Nick.
Hey, thanks, Jennifer. Just to make clear, these were all green fields. Is that correct?
Correct. Yes. Okay. Yeah, this was a brand new community, you know, that Washington County developed a plan for. And so from that, we were able to estimate a load profile based on what other new communities were, and then determine how much load we think would come to that area.
Thanks, Jennifer.
Yeah. Let's keep going, Shadia. Yeah, let's keep going. Let's go one more. Yeah, here we go. So with our current state analysis, when we're running this current state analysis for the system that is serving the area now, so this was the Bethany substation, we perform analysis where we take each individual feeder and transformer at that substation in both peak summer and peak winter conditions. So like your June 28th, 2021 type of summer and your, you know, February ice storm type of winter loading conditions, you know, the top time where we have the most demand on our system. And we apply that. And then we take individually, we run multiple different scenarios. So if we take, you know, for example, the first bullet here, the Bethany Germantown feeder, we saw that if we lost that feeder, and this was before adding that new load to the system. So we already found that we had some contingency issues here. So if we had, you know, our hottest summer day and we lost that feeder, we would have over 3 MVA of load that we could not serve because it would cause issues elsewhere if we tried to switch it to the other parts of the system. So that could be things like it could cause low voltage issues for customers because it's trying to be served from a substation that's too far away. We also found that our Bethany transformers did not have full redundancy during peak summer, and then one of them did not have it during peak winter either. So that was, you know, we already had system issues in this regard in terms of our redundancy. And so we didn't want to try and add 16 to 17 MVA of new load to that existing system because that would make things worse. Let's go to the next slide. Keep going. One more here. There we go. So, you know, one thing that we always do is we look at adding capacity to existing substations first. So our Bethany substation, actually, when we originally built it, we could not expand it. That was a condition of our approval when we originally built that substation. So we were limited in what we could do there. We could not add a third transformer without compromising the driving space within the substation, which is a safety issue. Our crews need to be able to drive within the substation and not be too close to that equipment. Cornell substation was energized in 2013. It can accommodate another substation transformer, but it is much further south from that area. It's the one that if you drive down Highway 26, when you get close to the Murray Boulevard exit, there's a substation right there on the side of the road and just north of 26 there. And so it's a newer substation, 2013, although now that I say that, I realize that's almost 10 years. But again, it is much further south than North Bethany area, so it'd be challenging to reach up there without having voltage problems because it'd be too far away. West Union substation, there was actually already an expansion planned in 2015 because we had such heavy loading at that substation already. And there was a lot of load growth targeted for that area, a lot of commercial and industrial load growth in that area that will be served by West Union substation. So we didn't have capacity to serve the North Bethany community development as well. So that was how we came to the conclusion that a new substation was required to reliably serve the load growth. And it also provides redundancy to adjacent substations. Yeah, so when we're doing, when we're trying to find property for a new substation, like I mentioned, we are limited in terms of what land zoning entails. So we cannot site new substations in certain zoning, certain land zoning places. So, we looked at, site one that had institutional zoning that was actually owned by Portland Community College, but they had expansion plans that utilized that land. So that was out. Considered site number 2 is the red one towards the top of the page. And that we had some access to the site that would be challenging. Trying to route transmission to serve the new substations is always a consideration. And that it had a very narrow driveway because it was just serving a few homes up there. And so it was a challenging site from an access standpoint. Considered site number 3, infrastructure routing options was a challenge here in that everything would have to go south from that substation. So we'd be routing all of our lines directly south. We didn't have any other road right of way to go down, just that one road. Then consider site number 4 is the one over to the far right. That one we had issues with routing transmission sources to the site. And again, this, like the other blue one, we had limited line routing options in terms of everything had to go to the west for all of our lines that were coming out. So our acquired site in yellow there, we have access to major roads, right along there. So you could go west, you can go east, and you can go a little bit west and then south. So it gave us a lot of different routing options for routing our lines. And it also, because we're close to those roads and we have the road right of way, it gave us access for routing our transmission as well. Yeah, I think I covered this. Does anyone have any questions? Okay. Oh, Nick.
Hey, Jennifer, thanks. Are the 67 and 80% thresholds company standards, industry standards, or a little bit of both?
They are company standards. I cannot say whether or not they're industry standards. I think I've seen 75% for feeders on some other utilities. That would require us, frankly, building out more feeder infrastructure in order to have more ties to other feeders so that we could keep that loading up to 75% and be able to still switch load around.
Okay, so it sounds like there's some consistency there, but it might vary from company to company a bit.
Yeah, I think so. And I don't know if anyone from another utility is on here who can speak to their criteria.
That's okay. It's really helpful for me to just understand that, Jennifer. Thanks.
Yeah.
This is Heidi Caswell from PacifiCorp, and it's consistent with setting thresholds in the range that Jennifer's talking about. It's consistent with here and other peers that I'm aware of.
Yeah, there's a question in the chat by Daniel. Yes, the limits are based on thermal standards.
I think, well, Jennifer, this is Andy from PGE. I just would think we often get questions about, because PGE is dual peaking, whether it's more or less of a problem in winter versus summer. And could you talk for a bit about just the relative seasonal ratings of the equipment and how that may lead to more summer problems that we see typically than winter?
I will do my best. summer, our ratings are always lower. Equipment that requires this much, that has this much electricity running through it generates a lot of heat. And so when it's colder outside, that helps keep that equipment cooler. So when it's warmer outside, we can't load it as heavy. Yeah, and winter, Andy's right, is dual peaking. So we typically see in the winter where we have, first thing in the morning, it's cold mornings and everyone's turning on their furnaces and all of that when they first get up. And so we'll see a peak in the morning. And then, load starts to drop off in the afternoon as things warm up outside. And then we'll see the evening peak that we see both in summer and winter around dinner time. Traditionally, when people would get home from work, that kind of thing. So summer, it tends to be because, you're not turning on your furnace in the morning, so you don't have to worry about that. And you see more of a traditional bell curve, for lack of a better term, in that it starts out lower and then gradually increases throughout the day till you get to your peak, in the 4 p.m. to 7 p.m. time frame. It just kind of depends on the day and what's been going on. And so then it drops off at night, of course. And we expect that, with the addition of some of these DERs on our system, some of that can change. For example, back in February, we actually had one morning where we had a loading issue in Estacada on one of our transformers because the sun wasn't out yet. And we have a 10 megawatt solar facility installed, and it wasn't online yet because the sun wasn't out. So we had a loading issue for a while in the morning until the sun came out and we were able to offload some of that with the solar.
Great, thanks.
Any other questions? Jenny?
Thanks, Jennifer. I have a question about how the load was forecast for the community. I'm not sure if this is the time to talk about that or if you're going to get down there later.
Absolutely. Yep, absolutely.
So the I guess my question is around what information goes into the sort of modeling and forecasting you're doing when you're considering a development like Bethany, and especially given the timeline. Are you looking at the state building energy code changing over the next few years? Are you considering the level of energy efficiency that's being required in the community? Just kind of general questions like that. Just what goes into the numbers that you're putting together?
Yeah, absolutely. So what went into the numbers was that, we look at other communities that have been built and we try and find a community that has a similar profile in terms of, how many units per acre were in there, hopefully energy efficiency developments. This was done quite a while ago, and so there wasn't necessarily, we didn't have as much visibility into it. I'll just be transparent. I didn't have that much visibility into some of that in the past. That is something that we certainly are considering more and more and will be part of our future process definitely in more depth. So we're looking at similar developments to the extent that we can. Some of these are just so large that some of these homes were just frankly really large, and there weren't other homes that were developed recently with that size. And yeah, some of them have some solar panels on the houses. We didn't have a ton of developments in that area with solar panels, so that was a little challenging as well. We ultimately took an average at the time, but now that we have this community moving forward, we can have a little more granularity into what we forecast for future communities.
Great, thank you. And is the forecast at an hourly level, or Or how granular do you get when you're forecasting?
Yeah, so in the traditional planning process, the current planning process that we have been doing, we were just planning to peak. So we're looking at the maximum amount of load that we would be required to serve. Moving forward, there'll be more of that 8760 look on forecasting.
That makes sense. That makes sense. And I think I had probably have a few more follow-up questions, but
okay,
I'll sit back for a minute. Thank you.
Jenny, just real quick before the next question, Jennifer. Jenny, we have been talking with Energy Trust, so the planning group, and I'm sure you're aware of the conversations around how to sort of leverage more, like I would love to in the future. I mean, we have ability to, coordinate with Energy Trust energy efficiency forecast for things like local reach codes and things, under either Executive Order 2004, if local jurisdictions, implement building codes and things like that, or if Energy Trust has kind of, a more granular depiction of where the above code homes are likely to be for new developments. And then I think there's a lot of coordination we could be having on that going forward. So we're hoping to, as Jennifer said, roll more of that specific end use load and also granular 8760 hourly load forecast into this process. And, we're taking a crack at it with the tools and data we have today. And so, yeah, happy to talk with you. I think we have a meeting coming up next week, coordinating with you all and PacifiCorp. So hopefully we can get aligned on what kind of data flows need to happen to really make sure we're tight on that.
Yeah, thanks, Andy. And I guess I would say that there's other opportunities, and it sounds like maybe that's part of the conversation, but I'm not sure around the actual development themselves. So if Energy Trust is participating, is helping verifiers, there's modeling happening on all of those homes, or like in the case of South Hillsborough, the community has decided what requirements all those homes have, and there's modeling that is very specific. That's not kind of an annual forecast. And so there's more opportunities for working together, I think, than maybe we've explored in the past, and may not be part of this conversation. So it'll be good to connect next week.
Yeah. Let's see. Eric. Eric, if you're talking, you're on mute.
Okay, sorry. My question is something a follow-up to Jenny's, and that is about electric vehicle loads. Last year, we saw global and U.S. Sales double, and it won't take many more doublings to pile up quite an extra load. What sort of modeling and the numbers are you expecting in like this kind of neighborhood? We know that 90% of charging occurs at home.
Andy Iden, do you want to take this one?
Yeah, and I was going to chime in earlier, but I mean, Bethany, this, like Jennifer mentioned, this project was done a number of years ago, but Bethany is an example. Along with like larger homes, we see a cluster adoption of light duty residential electric vehicles, and both in terms of historic adoption and projections. And so again, that's kind of when Joe kind of flashed that first slide, that's the transition we're trying to navigate, is getting the granular DER forecast that we have developed, including substation level and really feeder level EV forecasts, and then including those in the future sizing exercises and analysis. So right now, under the planning to peak that Jennifer mentioned, under the current state, you would kind of look at the coincident peak load of residential charging. And then as we move to explore the sort of hourly 8760 impact, then as charging load is very flexible if you have the right price signal. So, we've rolled out a residential smart charging program, pilot program. And so as we begin harvesting the learnings from that type of thing about how much our customers can shift load to the evening hours, I mean, that's beneficial to the grid itself as a whole, but then for the locational side, I mean, there will be a tipping point where even shifting to the nighttime hours, you're still, for local service transformers and things like that, you have to kind of consider all of those factors. And so we will be including that kind of in the filing in August. We'll talk about locational transportation forecasts, and then as it rolls into these type of substation or, you know, planning investments, that's going to be kind of on the future iteration next time.
Okay. Shadia, I think we can probably go. I think I've kind of dug in detail for most of these slides. Does anyone have any other questions? Eric, you still have your hand raised. I want to make sure you don't have another question. Okay. Okay, well, if there's no other questions, I'll turn it back over to you, Shadia.
Let's give 1 more minute to people. There you go. Nick.
I thank you for taking my question. I always want to be sensitive to leaving space for others. So, which means I always have a late hand raise. This was really informative to illustrate what I'll call status quo processes, and that might not be quite right. Just as we all acknowledge that this is kind of how things were done before and it's evolving now, but for what they were before, it's really helpful. Thank you. Can you step back and just sort of speak to, I mean, really at a high level, 3 or 4 sentences, like, how representative of a new, how representative is a new substation of typical projects and investments? You know, would this represent, and I don't know if you want to think about it in terms of project count or budget. I'm not sure what's the useful proxy, but the other part of the context that would be really helpful, I think, for people to understand is, you know, oh, like if this represented something really typical, 2/3 or 3/4 of most projects, that, you know, that would be informative. If it was more like 1 in 10 projects, that would be really informative too. And that's maybe something you can do on the fly or maybe not. But does that question make sense, Jennifer?
I think, and I don't know that I can give you any specifics. From what I can say in my 15 years of being in planning, most new substations were driven by new large load additions. So things like this new community, or things like in the North Hillsborough area with all the data centers out there, Intel, et cetera. So most new substations are driven by large load additions. Otherwise, we're looking to try and add capacity at existing substations. But in terms of specific numbers, I can't necessarily speak to that.
Okay. And that, let me, I don't think I asked that question very clearly. Okay. Is it, does typical, in a typical year, does the budget get spent mostly on new additions like this, or expanding existing facilities, or rebuilding? Again, just at a high level, like, is that something you can speak to?
That is something that Joe is going to talk about in detail tomorrow at the work group.
Okay.
Yeah, we're gonna take this.
Yeah.
Go ahead,
Yeah, in
Jonathan.
recent years, a lot of stuff has been customer-driven projects, so new large load additions or new communities, as well as compliance. So there's OPUC compliance, but there's also transmission level compliance. So we have to do transmission projects in order to meet national standards. And if we aren't compliant, we can get fined. So they're must-dos.
Sure. Thanks again. I echo Jenny's comment. Appreciate walking through this. And thanks for letting me push you a little just to understand the contextualization of this example.
Well, so I wanted to, add a few things. One being that in tomorrow's technical work group meeting, we're going to take a pass at talking through kind of the plan part. Like, what does the action plan look like? So if you think about the DSP requirements, it's needs, solutions, what's the plan? So we're going to pick up that conversation tomorrow and talk a little bit about it, and we'll get some good insight into how to talk about it. The different types of projects and how much of the work plan that we have each type of project makes up, at least from a dollars perspective. We can talk a little bit of numbers like counts of projects, but that's probably not as meaningful as the actual the dollars and how much money each of the projects consumes. I also want to encourage folks, like we said at the beginning, these are dense topics. This one and Nahid's conversation is going to be similar. Take time if you need to look at the slides after the fact and send us questions after the fact. Like as I said at the beginning, the intent is to start identifying data and information that's meaningful to you. Like, what do you want to know about the projects that we are initiating and how we got there? So if you need to, go through the slides again online on your own time to come up with some questions, that's fine. We can incorporate that stuff in one of the upcoming meetings. So, I encourage you to take another look at it and give us feedback.
We have scheduled time for questions. So maybe let's take a pause and see if there's anyone else that might have a question for you, Jennifer. We're on time with our agenda. Seems like it's clear, or maybe people need some time to go over and rethink about
Absolutely. Please
things that might have been not
clear. Take the time to digest and send us questions.
And thank you for being here, walking with us through this very technical process. Thank you, Jennifer, for doing your best to layman it for all of us, the non-engineers. Okay, so let's jump onto our next break. To replenish, let's take a brain break so that we can have the mental capacity for our next presentation. Let's meet back at 11.
No, no, no. That'll just be the muscle.
Welcome back, everyone. Are we ready to continue our DSP morning journey? We have one more presentation to go. And I would like to introduce the next speaker, my colleague, Nihicha.
Hey, thanks, Shadia. All right. I think Joe kind of mentioned this at the top. The idea here is to try and go through the presentation quickly at first, and then pause on certain details and kind of revisit it. And so we're going to try and use that same format this time. And so with that, Shadia, if we could move a couple slides ahead. Just to quickly recap, I think Jennifer, I guess Joe was talking about a similar slide earlier today with slightly better graphics, might I add. And so just to give you a sense of what we've been talking about in the last meeting, we talked about the fact that this year is a year in transition. And I think we've kind of touched on that theme multiple times today. We're going to try and change some of the things that we do in our planning process this year, with more changes in every subsequent year from now. And so some of the changes that we are incorporating this year is that we're going to share our prioritized grid needs and solutions. But I think in addition to that, we are also going to talk a little bit about non-wires, and that's what this conversation is going to focus on. So next slide, please. Just to kind of put this in sort of a slightly different perspective, if we think of each of these circles as different projects, like the Bethany substation or a feeder reconductoring or new customer load additions and things like that, we can see that there are several projects that that get identified, and then we prioritize some and work on a solution for them. Then again, based on real world constraints, like whether the load is getting materialized, as Jennifer mentioned earlier, and other real world considerations, we determine recommendations, and that's what we expect would go into the near term action plan, and then subsequently into our project execution. All right. The last recap before we sort of dive into the work is that we've been talking about a document which we call the Non-Wires Policy and Procedures document. The document lays out PGE's approach to non-wire solutions, including how we screen for the non-wire solutions, how we develop a solution itself, and how we define non-wires and sort of the ancillary components around it. This document was shared with some CBO partners last month and has been publicly shared, I believe, last week. Please feel free to use the link in these slides or go to our website. Or if you have signed up on our distribution list, you should have received an email as well. So the plan here is that we have completed our current state analysis. So at this point, we are presenting our grid needs, right? So going back to Jennifer's presentation, that's sort of the first 3 steps that she was talking about, right? So we've identified a problem. We've performed a current state analysis. The current state analysis is what tells us whether the problem can be addressed via non-wire solution. So it is at that point where we can say that, hey, yes, this is a potential non-wire candidate, right? And so that's where we are today. We are close to that step 3, and that's what we're going to talk about predominantly. The hope is that over the next couple of months, we have a larger degree of engagement through the various channels that Shadia has already mentioned, and this partner meeting exists. And we are also going to make sure that we are engaging with some of our customers, and then we will use all that information to develop the non-wire solutions, hopefully in May and early June. And we have a partner meeting in June there isn't a May partner meeting the way I understand it. Shadia, feel free to correct me. And in the June partner meeting is when we will most likely present the solutions. All right. So with that, let's dive into this section and what we are here to do today. So I am going to share all the information that I have put together with the team and the information that we think is relevant and useful to you. We want to understand and hear from you if this information is useful to you, right? If you need any additional information that will help you better understand the problem, any additional information that will help you understand how you can leverage any existing initiatives that might be ongoing and sort of bring that into the solution mix. So a large part of this is kind of us telling you with the intent that you can provide feedback on what's missing. And so the type of information that we're going to provide today ranges from the location, the types of customers impacted, the need, the time and duration of that need, what does it mean to have a contingency solution, and what are the potential solution options, right? So what are the technologies that lend themselves to a solution, right? So we want to make sure that the technology is available at the time and for the duration of the need. So I am extremely pleased to, if we could move to the next slide, to say that after sort of reviewing our potential grid needs, we were able to identify 5 non-wire candidates. And so these 5 are at the Ruby substation, which is on the border of Portland and Gresham. There is one in Dayton, Oregon, one in Hillsboro, another substation in Southeast Portland on Southeast 80th Avenue, and then one more in Clackamas. And so walking through each of these would be a time-consuming effort. And so what we thought was it makes sense to focus on one of these. And so today we're going to focus on the Ruby substation. And specifically, there are 2 feeders that come out of Ruby substation, that is Ruby Junction and Ruby Carline. And we'll be talking about what is happening there and how a non-wire solution could potentially mitigate that problem. With that, if we could move to the next slide. So let's start with how you can get access to what is happening at the Ruby substation, right? So if you go to our distributed generation map, which is available on the website, you can search for Ruby and you can find the Ruby substation, Ruby Carline, and Ruby Junction feeders, right? And so if you click on any of them, it should highlight the portion of the feeder highlight the portion of the map that is served by the feeder. And the idea would be that if you have some form of if you represent customers in these areas or are involved with some initiatives that overlap in these areas, we should definitely be partnering on how we think about our solutions, right? Leveraging the additional work that has already been done on the distributed generation map, on the next slide, you can also review some of the equity metrics, right? So I have selected a few different metrics here associated with income, and they kind of tell you based on the GeoID what the estimate is. On the next slide, we do a similar thing with disabilities, right? So we're focusing on the fact that yes, there are multiple jurisdictions that are impacted within this feeder area, and some of those jurisdictions have a higher percentage of non-institutionalized populations with disabilities. And so to that end, we know that our solutions need to account for these types of needs, right? And so that's kind of a starting point in how we think about solutioning. And so if this information is helpful to you in how you are thinking about how we can best serve these customers, please let us know. If there's more information you need, please let us know as well. All right. Let's understand the problem a little bit, right? Like, so now we've established where the problem is. Let's understand the problem. So there is as Jennifer mentioned, there is a 67% threshold that we keep on our feeders. That 67% threshold is represented by the red line that's going horizontally at about 12 MVA. And for those of you that are wondering between MVA and MW, so that's just a function of how we think about alternating current and phases. So like I would, for those of you that are uncomfortable with that, I would think about it in similar terms with megawatts. The difference would be 0.95, which is our power factor. But if for simplicity, if it helps, please consider this like more or less to be megawatts, right? And with that in mind, our current projection shows that around 2026 is when we will pass that planning threshold. Now, this is based on our forecast. And as we have identified a few different things, our forecasts are in the process of getting updated. And so there are pieces that are not necessarily accounted for in this forecast that would be accounted for in the future. So this forecast may change as we move further in the process. Next slide, please. So what's happening at this Ruby substation, specifically the Ruby Junction feeder and the Ruby Carline feeder, right? So at Ruby Junction, we saw that the load growth is going to exceed the planning threshold by 2026. When we did our current state analysis, what we found was there are no violations, right? So there's no issue with the feeder itself, but it's above the planning threshold, which means that if there was a failure of one component and we had to shift load, it is possible that it would have issues during that emergency condition, right, or the contingency condition. And sort of behold on the column to the right, there are thermal issues when we assume a contingency condition, right? So when we have to serve our customers with a different feeder, so that means Ruby Junction is down and the load is shifted onto Ruby Carline. Ruby Carline would then have significant thermal issues, right? And those thermal issues add up to about 3.5 megawatts. And so the hope is that we are alleviating about 250 kilowatts on the Ruby Junction feeder and about 3.5 megawatts across both Ruby Junction and Ruby Carline, right? So again, just to restate that, Ruby Junction is the one where we've identified the issue, and the issue is about 250 kW above the planning threshold that we want to try and mitigate at a minimum. And the expectation is that in an N-1 condition or a contingency condition, this is when the load has been shifted to Ruby Carline, we would need to alleviate another 3.5 megawatts. So, and then to understand where along the feeders can we deploy our solution, the answer in this case is across the entire feeder, right? So all customers being served by the feeder are potential solution, are part of the potential solution, right? And so that's kind of in a sense good news, because now we can focus on behind the meter solutions, including energy efficiency, demand response, and solar and the like. Finally, we want to talk about the violation. And so the violation happens from about 3 p.m. to 7 p.m. So towards the evening in June, so on mostly summer, and on weekdays more than weekends, right? So this is important because we want to make sure that a solution that is applicable is also available during these times, right? We need it to make sure that it is performing at the level it's kind of rated at, or it's expected to during these times, right? So that's the most important thing. Next slide, please. I'm going to go through the rest of this quickly and then kind of come back, right? So these are our seasonal load profiles. So going from the top left, clockwise, it's winter, spring, autumn, and summer. Shadia, if you could click next for just a moment. Our problem areas are roughly between 3 and 7, as we discussed on the previous slide, and you can see that that's roughly when the system is peaking. And you will note that even though the winter peak is slightly higher, because of the seasonal ratings that Jennifer was talking about earlier, it's not as much of an issue in winter as it is in summer. All right, next slide, please.
Also, it's important to note that those are average profiles, and so even though we might have longer duration peaks in the wintertime due to cold snaps and things like that, the summertime spikes tend to be spikier and, I mean, more and more frequent in recent years. But so that's where the average load profile over the season there is not going to reflect. It'll be accentuated essentially on that warmest day.
Yeah, that's a really fair point. Next slide, please. Let's quickly walk through some. Yes.
Hey, Nahid. Hi, this is Steve McDonald. I'm curious, are you guys only worried about those coincidental loads for that 1 or 2 times during the year? Or are you looking for solutions that can manage the whole feeder for the entire 8760 and sub-hourly?
Yes, so we are the problem. So the opportunity is around that 3 to 7 p.m., right? So we would build a solution. So we would spend ratepayer dollars to build a solution for that problem. And so an alternate solution must mitigate that problem. Solutions that provide other services, but not at those times, will not get any distribution deferral value or the locational benefit of this grid need. Does that help answer your question?
Not really. So what I was asking for is that time range. Are you only looking for like 2 times during the year, the coincidental time period? Or are you looking for 3 to 7 from January 1st all the way to December 31st for every single day of the year?
Yes, so as I mentioned,
two different versions of that.
Yeah, as I mentioned, our focus is currently for summer. So let's say we're able to address part of this issue with solar or batteries. Their primary use case from a grid operation standpoint would be to provide this distribution relief from 3 to 7 in summer. Outside of these hours, they might be able to provide other services that might extend to the bulk system, such as frequency response or capacity.
Okay. All right. Thank you.
I think, Stephen, this is Andy. I mean, in short answer, yes, we are interested in how those resources like our daily load shifting for water heaters that we've talked about at previous meetings. We're exploring, how system value can be derived from operating those throughout the 8760 period. What Nahid's kind of indicating is just as we integrate with distribution planning for trying to, identify non-wire solutions, we're primarily focused on that coincident peak at the system level for that distribution feeder, which happens to be summertime 3 to 7 for this feeder. So other things, other values of a potential DER solution could enter into the economic calculus of a ultimate, whether it be a utility or an energy trust incentive or some other way of providing that support. It would be part of the calculation, but not for when we look at it from a distribution, like what problem we're trying to solve, like Nahid said. In this, in this context.
In this first iteration, right? Okay.
Yep.
That makes sense. As we move forward, I mean, the exciting stuff that's going on about 8760 adjustment needs to be considered as well in distribution. So I'm happy to support that effort in PGE and others. Excellent. Thank you.
All right, so let's talk about who the customers are, right? Like who's really impacted by this issue. So it's predominantly residential customers with small amounts of commercial, small and medium commercial, and then and some that we have categorized as other. Within the commercial segments, you can see a large part of this is commercial offices and merchandise stores. But you will also note that there is 4% of healthcare and some government education at 4% as well, right? And so keeping that in mind, as we think about our solutions and sort of the potential partners we could work with, these are the buildings that we can interact with as part of developing our solution. Right. Next slide, please. So given that the problem is coincident with summer evening, that sort of initially tells you it is cooling related. And if it is cooling related, then it is likely that the heating and cooling system is going to be one of the potential sources for solutions, including insulation. And so we have highlighted the breakdown of heating system fuel by housing type. And so what you can see is that the multifamily houses are largely electric, and the manufactured homes are split almost evenly, with single family dominated by gas in this instance. And so the hope or the expectation would be that if there is an overlap on the cooling side as well with multifamily, that we could get solutions that help with both heating and cooling that apply to multifamily. And if it's driven by air conditioners on single family, then that's largely associated with improving the air conditioners in those homes. All right. Next slide, please. Let's understand who is living there. So we understood a little bit about the buildings, a little more about the people there. There are about 5,900 premise IDs that we count served by the Ruby substation. So this is across both Ruby Junction feeder and Ruby Carline feeder. We find that most of them are multifamily rental properties, which is a traditionally hard to serve market, which we think provides a great opportunity. And if you look at the table below, you can see that over the last 12 months, significant amount of energy assistance payments were made to this to the multifamily market segment in at the Ruby substation, right? And so this, in a sense, provides a great opportunity for a solution to try and address multiple policy goals at the same time, right? Like, so we can help with our environmental justice goals as well as our sort of reliability needs, hopefully in the same solution, right? So this kind of tells you that seems possible. Obviously, as we get into the solutioning, we will figure out what that really means. All right. Next slide. So what is going to happen on this feeder from a DER forecast perspective? We are hoping that or we are estimating, I guess, that by 2026, we should have significant penetration of residential thermostats, peak time rebates, flexible water heaters, residential storage is just a little bit, and a non-insignificant amount of PV. And so the hope is that these forecasts will in part help alleviate some of the load, but we want to make sure that these forecasts, are realized, right? They are our best estimates, and obviously they need to come to fruition. And so the non-wires would sort of help not only bring these this forecast to fruition, but maybe even push it further, right? And again, the need here is about 3,500. So you can see that there is a significant amount of gap that needs to be addressed in 2026 between that about that 2,000 kW mark and the 3,500 kW mark. And so Again, this is the forecast without a non-wire solutions in place. This is what we think is going to happen, in a business as usual case, if you will. And so just kind of helping you understand that. So this is the nameplate capacity. Obviously, there are capacity factors, and this doesn't translate one-to-one as to how we see the energy on the system. So on the next slide, we've provided a little bit. We've provided a little bit of how these resources would provide their value and at what times of the day, right? And so potentially, if all these programs were combined, you can see that our need is from 3 p.m. so 15 there to about 19 there, and you can see that the distribution peak happens as the sun is setting to a certain extent, and so solar can be part of the solution, but will not be able to necessarily address the entire solution, right? And so this is a sort of a critical thing that we need to think about as we consider what potential solutions make sense to address the need, again, from 3 to 7 on this on both of these feeders. All right. So next slide, please. So we talked about what we think is going to happen, right, in the business as usual case. What could happen? And so to put it in perspective, a high case shows that we could get up to 3,000 kW if policies and costs and everything kind of line up with assumptions in our high case forecast, right? So this is, again, in the absence of non-wire solutions. We think that if everything lines up, we could, our forecast varies between 2,000 and 3,000 kW, a little over 3,000 kW, depending on our assumptions, right? And so if you go to the next slide, this talks about the technical potential. And I want to talk only about demand response specifically, because if you think about solar and storage, they can be put on every home. So they have very significant amount of technical potential. So it would sort of dwarf the graph here. And so just thinking about demand response specifically and how that can be used to reduce the bills of folks that are living here, you can see in 2026, demand response alone could bring us, significantly higher demand response capacity than our high case, right? And the hope is that we are able to unlock some of that technical potential. We cannot unlock it all, because I want to kind of stress that technical potential doesn't account for some of the real world challenges, right? Like maybe there isn't the technology can't be installed, right? Like a heat pump water heater can't be installed because there isn't enough space for the air to circulate, or they recently installed some new equipment, so they can't necessarily change it. So there are some parts of the technical potential that cannot be achieved, but we want to try and achieve as much as possible. And so depending on the cost of the wired solution and the locational benefit of that, we would be able to capture a part of this technical potential, right? A larger part than hopefully the high case. And so that's probably the direction that we would want to head with our solution. So we want a significant amount of demand response, definitely some thoughts around solar and storage. And I have not included energy efficiency here because we don't have granular energy efficiency forecast, which I think Andy alluded to earlier in the conversation with Jenny. And so with that, I think it makes sense to kind of go back to the earlier slides and see if there are any specific slides we want to spend more time on, or if there are any questions that we can help address. Yeah, I think that should be good. Yeah. All right. And so what we could do is kind of go through each of these slides, just touching upon some more ancillary topics. And if there are questions, please raise your hands and we can help address them.
We have a question from Jenny Hall in Heat on the chat.
Yes, how was the hourly solar profile generated at the feeder? That was using PV watts.
Thanks, Nahid. And the input from that was the existing solar systems on the feeder, knowing their capacity and tilt and orientation, or?
So in this case, we are talking about the forecast. So it is about expected future systems based on roof size and other things. I think Andy can provide a lot more detail as well.
Yeah, the current state in 2021, we took the PGE interconnection log, which tracks the nameplate kW of the panels and does not have that sort of tilt orientation and things like that that are, I think, Jenny, part of the conversation we've been having with Energy Trust and you all as part of the Power Clerk kind of data sharing. And so I think I'd love to incorporate that into this going forward to get, you know, as we zoom in on areas of the distribution grid to be able to say, how does those other factors of the solar systems kind of, as they're installed today, change the output shape or the daily shape of the solar resource? And then, like Nahid said, since this is like a projection of 2026, I mean, we make assumptions. I think there's always room. You could like make better modeling granularity about, you know, which home is likely to adopt solar and then what's the shape of their roof and that type of thing. So, I mean, there's a lot of questions we could answer, you know, in a collaborative fashion in that sense. So if you're interested, I mean, I would love to improve the granularity there.
Yeah, and just to underscore that point, you know, we are doing a bottom-up forecast, and we are trying to estimate the size of the solar system based on the roof and the orientation of the house, among other factors, including economics. In some cases, we don't have information on like the age of the roof or some of the specifics of like some houses, right? And so we may have that information for some buildings, but not for other buildings, and we make statistical assumptions based on a representative sample. So if we get more data around what it means, or what's the site information available, we would be able to update those assumptions and better reflect those in our forecast. And that kind of gets to the more granular and more improved elements of the forecast that Andy's referencing.
Thanks, Nahid. And the current forecast, this is based on the initial distribution system planning forecast that Kadeo worked with you on, or is this the new NREL work that you're doing right now? Andy?
So those are both the same. Yeah. So yeah, Kadeo's model, the adopter model that we built and have used, leverages DGen. So I've provided a rundown at the last technical work group of that, and I can share the slides with the attendees here if you're interested. We go into some detail, and there's, I think maybe Jenny, what you're getting at is there's like future work to improve on the DGen side actually. So there's some R&D that's sponsored by the DOE, working with EPRI and NREL, and NPGE has sponsored some of that to try to get more granular approximations of, you know, the agents within PGE service area. And that's going to be work that continues over the next year and 2 years. But we're leveraging DGen. So that is the forecast, and that is being shown there. And what we're doing over the next, I'd say 2 to 3 months, I mean, we're going to have a new forecast here to present in a couple of weeks. We'll probably socialize that with this group, you know, later in April timeframe or May. And then once we, you know, I think Nahid talked about the 5 candidate substations. The plan is once we sort of land on if we're doing all 5 or 2 or 3, some subset of that, as we can engage with you all and others, you know, in our community engagement sessions, we'll have ability to sort of take another pass and look at things at that more targeted locational level and include things like, you know, new programmatic incentives or other things, or different ways to say what solutions can we bring to bear and do we want to look at.
Thanks, Andy. Thanks, Nahid.
Stephen, yes.
Yeah, hi, Naheed. Thanks again. So for the potential solutions technology options, you highlighted DR. Can you speak a little bit more about, how you wove in equity into that DR decision? Kind of, DR is, a supply side approach, which is like an aggregator system, kind of a VPP, or it's a demand side approach, which uses retail rates and everything. So I'm curious, one of those solutions still keeps participants non-equitable and they treat them as passive participants. The other one treats them as active participants and very equitable focused. And so I'm curious if you guys are considering that equitableness in your DR approaches. And if, you need a further understanding on that, I'm happy to support that.
Yeah, those were a lot of big words. I'm not sure I tracked on how all of them like come together necessarily. But I will say that we aren't considering just demand response, right? The OPUC has defined DERs to be front of the meter solutions, behind the meter solutions, including energy efficiency, demand response, solar, and storage, right? And we also include electrification, like transportation electrification and building electrification within our work, right? In this case, since we're thinking about load relief and savings, we are thinking about the resources that can provide that. And that includes demand response, whether that is from managed charging, heat pump water heaters, thermostats, peak time rebates, what have you, energy efficiency, batteries, solar, and front of the meter solutions, which also may be batteries or solar, right? And so we're considering all 5 of these, and we will create a solution that is, if we had no input whatsoever from the community, right, we would create a solution that provides us the best long-term rate reduction, right? So that is sort of the cost optimal solution. And if we get input from community saying that, hey, we would prefer these types of solutions, or we think these types of solutions make sense because of other initiatives ongoing, we would account for those and then look at the change in both the rates and the equity impacts, right? And so when we're thinking about our solutions and how they impact both long-term rates and short-term equity, that balance happens through the matrix that we had discussed a few presentations ago, right? So we create a matrix where we basically evaluate each element, right? And I think Jennifer mentioned this earlier. They evaluated like the consequence of failure and sort of the outage minutes and all of that. So in that, we would have a metric around equity, right? That could be the community benefits test. That could be the reduction in the energy assistance payments. It could be electricity burden. So we are working with the community to decide what is the appropriate metric, and then leveraging that metric to define what success looks like, right? And so the idea is that we would sort of balance that with the reliability, safety, and all the other pieces that Jennifer's talked about in sort of the historical process or sort of the traditional process, and then we would score all of them to determine what is the best option to meet our customers' needs. Does that answer your question?
Yeah, it kind of gets around about it. But no, I'm speaking more about the solution itself. And so I won't try to use big words. I'll use just simple words. So DR can be aggregated like in a virtual power plant, and that's using some kind of software and keeps the end customer as a passive participant in the solution. Okay?
Yeah.
There's other DR approaches called the demand side DR approaches. Those uses time varying rates, dynamic agents, for load control. And that is what allows the participant to become active. And so my grandma or your grandma or whoever lives in this service territory area, they get to select when they want to behave with those dynamic rates. Okay. And so HB 2021, as everybody knows now, is addressing these dynamic rates and creating these market mechanisms. I'm curious, how are you weaving in that equity component into these solutions? I understand the matrix and everything, but I didn't see in the matrix where you're considering moving people from passive participants into active participants?
I would say that when I say demand response, I am talking about pricing and non-pricing programs, right? We're not thinking that we're not taking any solution off the table, right? We want to understand from the community, what do they prefer? If they prefer passive solutions where they don't have to be involved, then that's what we will prioritize. And if they have no preference, then we will prioritize what is the cost optimal solution, right? And if they prefer having a different time of day compared to the rest of the territory, we will see if that is a potential solution that we can offer, right? We have the AMI infrastructure. We need to make sure that all of it is available, all of it can be built specifically. We also need to make sure that the PUC we need to work with the PUC to make sure that we have certain customers on a different rate schedule compared to everyone else in the territory, right? Like, and that there's an equity question there, like, just because I live here, do I have to pay different rates, right? And so these questions need to be addressed. We're not taking any solution off the table to your core question.
Brilliant, brilliant. That sounds good. Thanks.
So Shadia, if we could go to a few slides over, further down. Yeah, let's go to the customer section, I think. The next slide. Sorry, the next section, please. So I, again, want to note that majority of our solutions are going to be residential focused because most of the customers are residential, right? And so it's likely that energy efficiency savings around insulation, windows are going to play a large role, given that it's a cooling based issue for the most part. We will also double check that that's the biggest driver. You know, sometimes even though medium commercial there is roughly 72 premise IDs, 71 premise IDs, they could have a larger contribution to the peak, right? So we will kind of determine how each of the segments is contributing to the peak, and then use that information to better develop the solution. So just kind of highlighting that for everyone to think about that. And Shadia, if you could go about 5 more slides down. Sorry, 2 more. Yeah, a couple more. 1 more. Yes. And again, I want to mention here the reason we haven't added the other DERs in this picture is because front of the meter DERs don't have a potential, because you need to like acquire land and like set it up. So there isn't like default potential available necessarily. And so we don't necessarily calculate that at the moment. Energy efficiency is not calculated because we don't have granular forecast for energy efficiency. We're working with Energy Trust to see how we can get that. And solar and storage would be quite large because they could be applied to every building. And so they would basically dwarf the chart. And that's why they are not included. So it's not stating in any way that this is a preferred solution or preferred technology. This is just kind of stating the fact that this is one technology that has a significant amount of potential. And, you know, as you can see, even if we got all the technical potential of demand response, we would still not meet the problem, right? So if every home had peak time rebates, thermostats, water heaters, smart charging, and residential, all of these, it would still not be enough. And that's kind of the point I want to make, that the size of the problem is pretty large. Is the intent to select 2 projects from the non-wire solutions and non-wire candidates identified? What is the criteria that will be used to make that down selection? So Jenny, the hope here is to work on all 5, right? Like, so we filtered it down to 5. We're going to work on all 5. Some of these will fall off the table because it's just not possible to get that level of like adoption of these technologies. Some of them may fall apart because the forecast may change, right? Like as we've talked about. So we aren't necessarily deciding to reduce the number, but we think that as we go through the process, it's likely going to drop off organically as a function of some reason that we don't know yet, right? And if it all works out, then we'll kind of be where we are. And so that's kind of our thinking today. And as we go further, we'll obviously take into consideration things like the amount of engagement that's required, right? Like there's bandwidth concerns across stakeholders, communities, and PGE that we need to consider. Can we all do 5 projects? And maybe that becomes a reason for reducing it down. So we don't have a process to reduce the candidates at the moment. We think that it could happen, but we're not working towards it. Does that answer your question, Jenny?
Yes, thank you.
Right. Any other questions? Yes, Nick, please.
Hi, Nahit. Thanks for walking through how you guys are thinking about approaching this, and I appreciate the context of, you know, the hypothetical model coming to bear on the real world. So I appreciate you guys taking the time and really going through some dense material for all of us. I had 2 simple, just clarifying questions, I think. Shadia, if you would go to slide 70, please. As she's doing that, the question I had, Nahit, was, is it in the upper left-hand corner? Would the just verbal, or not verbal, but just, you know, clarifying definitions, would the violation be the 67% issue that would crop up in 2026?
Yeah, so the violation is when it goes above that, right? And so gotcha. In this case, it's a thermal violation. Yeah. And a few slides back where we talk about the 5 candidates, you'll notice that one of the candidates has a voltage violation as a function of like how long the feeder is. So the violation type is kind of a function of the grid need, if that helps.
It does, and I was relating this to the next slide, I think on 70 or 69 rather, the preceding one, and then we just so the if I understand the upper left correctly, the violation is not current now, but it would be above the planning threshold, meaning it would occur some period in the future in 2026. Is the threshold 10 years that you're looking at? The planning, the window?
So that window is kind of arbitrary. There isn't a specific time we are looking at. We expect that it would be above the planning threshold in 2026, but with the kind of freak year that we had last year, it was above the planning threshold then as well, right? So we did account for some of that, but our forecast doesn't necessarily show that, because if that's the forecast, then you would not expect this year necessarily to have the same kind of heat domes as well, right? So in a sense, we do expect the forecast to kind of go down from last year and then ratchet back up to the point where in 2026, we expect it to go above the planning threshold, right? And so if we get 3.5 megawatts, we might be able to offset that, I don't know, by let's say 3 years. And then if we can get 10 megawatts, we might be able to offset it by 10 years, right? And so we would have to balance how much we can procure versus how much we need to defer it. And that will be a function of how we create the solution.
Okay, thanks. Shadia, on slide 74, I just wanted to ask one other quick, I think, clarifying question. This is heating only, right? And so, Nahit, did you say something about the cooling system because if I understand the June timeframe correctly, it's good to know the heating system, but we really want to know the cooling system for these buildings, right?
Yes, absolutely, and that's a great point, and I think that kind of will get to the last couple of slides that I'm talking about, where we want to know what information will be helpful, and this is absolutely one of those things, right? And so we will make sure that that is available. Heating fuel is usually the first thing that people think about, and so that was kind of our first approach, saying that this is what's happening generally, and then we kind of break it down a little further.
Okay. Okay. Thanks, Nahit. Appreciate that.
Yeah, and Nick, I mean, part of the other side of the coin, I think Nahit mentioned a little bit, it tells you somewhat of your solution, because if you're trying to solve a summer issue by taking your air conditioning and making it more efficient, then understanding what the heating system baseline is important to know what the impacts of putting in heat pumps, for example, would be, which add winter load. So yeah, admittedly, we should have included the cooling system along with this. It's harder to tell about who has room ACs versus connected ACs and things like that. So we kind of want to dig in more with Energy Trust, hopefully, to look at maybe or other regional partners who might have better insights. But we do have some information, we just didn't include it. So sorry about that. But we'll in the future we'll include that.
Understood. I think thanks, Andy, and the I was going to say disparity. That's not the right word. The difference between the multifamily and single family homes is really telling, both in terms of the fuels, like you're just saying, but also programmatically how you would approach them as well. Okay, thanks everybody very much.
If you, Shadia, if you could go to slide 82. All right, so I think this question's already come up in the chat. And so first off, can you please reach out to us and tell us what additional information do you need to better understand the problem, right? And Nick made a really good point. Knowing what the cooling distribution is would be a great, would be good information. That's totally fair. We will provide that. And sort of, if there is any other information that you think is relevant in you better understanding the problem at this stage, please let us know. Next bullet, please. Please reach out if you have potential solution opportunities, right? So there may be a row of townhomes and the homeowners association is thinking of changing the roof because the roof is a shared commodity. It would be a good opportunity to partner with that to see if solar is an option, right? There might be work that is being done by the federal government, either through our HUD funds like the Oregon Housing and Community Services, state agency and other existing initiatives. If there is work that is ongoing that we can leverage as a way to partner and help serve our customers to the best of our abilities, we would like to know that. And if you have information about this, please reach out to us and we will 100% consider it and see how we can leverage that in our solution. So to sort of reiterate something I mentioned earlier, we have 5 candidates that we've noted. I have shared the information of 1 candidate. Our hope is to make similar slides available for all the candidates and kind of maybe publish that on a website. But if you have preferences of like, no, we would not like slides, we prefer PDFs, we prefer it via email, not published on the website, any of those preferences, please let us know and we can make sure we are accommodating that as we share sort of these grid needs and how we are working towards a solution. Lastly, I would request that you try and provide the solution opportunities by May 1st so that there is adequate time to actually implement them within our solution, right? Because if, for example, let's say there is an existing effort with the Portland Clean Energy Fund work or something like that, there is a lot of coordination that is required, and we want to make sure that we're submitting a solution when we submit the DSP. So by May 1st is what we are hoping can be the date where you start providing all this information at the latest. With that, we can move to the last slide of this section and just kind of stating what we mentioned up top, that we're going to do this work. We are engaging with communities on multiple fronts, including the previous slide, and we are hoping to develop the non-biased solution starting in May, with the expectation that we will present the solutions in June that include all the inputs and which inputs we cannot accommodate. And then we will document that and sort of package it within the DSP. Any final questions here before I hand it over to Shadia for the closeout? Oh, and thank you, Andy. Andy has posted what the AC penetration is across the housing types. So feel free to take a look at that. All right, Shadia, I will hand it over to you. Thanks.
Thank you so much, Nihit, for that presentation. Thank you for everyone that participated in this discussion. We have been taking lots of notes. Thank you for your questions. We are right on time, so you can get to your lunch. Our next meeting, as I mentioned at the beginning of the meeting, will be April 27th. Again, if this is clashing with any other meeting that might be scheduled with other stakeholder groups, let us know so that we can find a better time to move this meeting to. We would love to hear your feedback. I posted on the chat a link. Let us know how we're doing. What would you like for us to improve? And we're always welcome all your feedback. And I think that's all we have for you today. Thank you so much for your participation. And we will see you tomorrow. To the people that will be at the OPUC working group, we have another presentation, as Joe mentioned, on our capital portfolio investment lifecycle. More info there. So thank you for your time, and we will see you in a month. Take care.